Hi everyone, good evening. In this video, what I'm going to do is solve some of these practice problems that I gave for test 2. Okay, so let's look at number 1. The number of accidents at a certain intersection is a Poisson random variable. So good, you don't have to think a lot. You're told that it's a Poisson random variable. The probability that there are 2 accidents in any given week is 3 times as much as the probability that there are 4 accidents in any given week. Find the probability that there are no accidents at the intersection the next week. So what's going on in this question? If you look, normally for questions with Poisson random variables, you're given the rate at which these rare occurrences occur, like so many per week or so many per day, etc., etc. But in this, we're not given anything. We're not given any rate at all. All we're told is that it's a Poisson random variable. But there is this important piece of information that helps us. The probability that there are 2 accidents is 3 times as much as the probability that there are 4 accidents in any given week. Okay, so let's see how we can use that. The question asks for the probability that there are no accidents. So let's say let x equals number of accidents at intersection in a week. Okay, so we want the probability x equals 0. That's our goal. So we know it is e to the minus lambda, lambda to the 0 over 0 factorial, so basically e to the minus lambda. But we don't know what lambda is. So what do? We will use this statement and see how we can find lambda. So we're told that the probability x equals 2 is equal to 3 times the probability x equals 4. Correct? So let's write that down. E to the minus lambda, lambda squared over 2 factorial. That's this probability. And that is 3 times this probability x equals 4, which is e to the minus lambda, lambda to the 4 over 4 factorial. Okay, all right. So what can we do? You can see here's an equation in lambda. Let's cancel out what we can. So we know we can cancel the e to the minus lambda. Obviously, lambda is positive, so let's just solve for it. And what are you left with? 4 factorial over 3 times 2 factorial equals lambda squared, right? And what is this? This is just 4, and that's lambda squared. So that tells you lambda is 2. Use that in here, and this is e to the minus 2, or 1 over e squared. That is the final answer. Okay? I hope that made sense. All right, let's look at the next question. In the next question, you have a standard deck of cards. You shuffle the deck and randomly pick a card. Note what it is. Then you replace the card and repeat the process till you see 5 aces. What's the probability that you have to pick 10 cards? So you know there's a name for this random variable. You want to know the probability that you need to pick exactly 10 times to see 5 aces. That is a negative binomial. But you know what? It's okay even if you don't know the name of it. So let's write down what is happening. So we want, there's 10 pickings, okay? So 1, okay? 10 pickings of cards, and we want the probability that there's 5 aces in there, but we are seeing, we needed exactly 10 pickings to see the 5 aces, so that is an ace, and totally 5 aces, so in here there's 4 aces. in the first 9 picks. Okay, so if let x equals number of aces, you don't have to. We can just write the probability of 4 aces in first 9 picks. Intersection ace on 10th pick. That's what you want, right? So you could have just taught it out without remembering what the negative binomial random variable is about. Okay, well, there's independence of picks because it's first well shuffled. So this intersection is the product of the probabilities. This is a binomial random variable, n equals 9, and p equals the probability of an ace in a pick, which will be 4 over 52 or 1/13. Okay. And the probability of ace on 10th pick, we just looked at that, that's 1 over 13 because we're replacing it. Okay, so what's the probability that this binomial random variable is 4? It's 9, choose 4. Probability of success raised to 4. Probability of failure raised to 9 minus 4, which is 5. Okay, so that is what the probability is for needing to pick 10 times to see exactly 5 aces. Okay, you could put this together. It is 9 choose 4, 1/13 raised to 5, 12 13th raised to 5 because I put this and this together. Okay, so that's the final answer. Okay, so I hope that was good. All right, let's do question number 3. The density of a random variable is f of x, which is c over x squared when x is bigger than 10 and 0 otherwise. We want to find the probability that x is bigger than 20. Now, you see, looking at this density, you know that this is a continuous random variable we're talking about. And for a continuous random variable, the probability x is in b is the integral over b of the density. Okay, so in this case, the probability x bigger than 20 will be the integral over the set 20 to infinity of f of x. Or if you want, you could write it as the limits. But what is f of x? It's c over x squared. So when we evaluate this integral, we'll have it in terms of c. That's not good. We need a number. All right, so let's find c. How do we find c? We know that the integral from negative infinity to infinity of f of x dx should be 1. But what is that? F of x is c over x squared when x is bigger than 10. So this is 10 to infinity of c over x squared dx. Or if you want to do the limits business, b going to infinity, integral 10 to b, c over x squared dx. Okay, evaluate that. What is it? Cx to the minus 2. So cx to the minus 1 divided by negative 1. Okay, this is just some improper integration. And now you plug in b. B as your x. And then minus minus will be plus c over 10. Right? And as b goes to infinity, that goes to 0. So the answer is c over 10, which implies, and this is 1, so c is 10. All right, so then you can plug this in to this. So now you have the integral 20 to infinity of 10 over x squared dx. And I'm just going to write this down. What do you get? Minus 10 over x. And limit b going to infinity. Minus 10 over b plus 10 over 20. That is 0. And the answer, therefore, is a half. Okay. All right. So we'll stop there in this video. All right. And continue in subsequent videos. Okay. Hope that made sense. Let me know if you have any questions.